In the words of Anonymous, mathematics may not teach us to add love or subtract hate, but it gives us hope that every problem has a solution. Now let us take a line segment AB, and there is a point P on AB, so that PA is equal to P. P is equal to P. And A can be denoted with order pair x1, y1, and B with order pair x2, y2. If we know AB, then we can find order pair P. Here P dividing AB into two congruent parts. So P is midpoint of AB. Let us write the formula for bisecting point of a line segment joining AB. Bisecting point of a line segment joining A x1 y1 B x2 y2 is bisecting point x1 plus x2 y2 and y1 plus y2 y2. Here, as P is the midpoint of AB, we can write P as midpoint formula x1 plus x2 y2 and y1 plus y2 y2. Ordered by x1 plus x2 y2 and y1 plus y2 y2. We can come to know that P is dividing AB in the ratio 1:1. That means PA is to PB. PA is to PB. Let us take PA as some K units and PB as also K units. Then P is to PB is K is to K. K is to K. K in K one time, K in K one time. That is 1:1. P is to PB is 1:1. The point P, which divides the line segment AB in the ratio 1:1, is x1 plus ordered by x1 plus x2 by 2, y1 plus y2 by 2. The point, on the other hand, we can write it as the point which divides the line segment joining A x1 y1 B x2 y2. In the ratio 1:1. Is x1 plus x2 by 2 ordered by x1 plus x2 by 2 y1 plus y2 by 2. So as P is midpoint of AB, as P dividing AB in the ratio 1:1, 1:1 ratio, P is to PB is 1:1. So that we can write P as ordered by x1 plus x2 by 2, y1 plus y2 by 2. If not the midpoint. If P is not dividing in the ratio of 1 is to 1, at that time we cannot use this formula. We can use section formula. Let us go with the section formula. There is a line segment A. A is the point with order pair x1, y1. Point B is denoted with order pair, this time with order pair x2, y2. And there is a point P. So that P is dividing AB in the ratio M1 is to M2. That means P is to PB is equal to M1 is to M2. That means P is some constant. P is M1 into Km1 and P2 is for some constant Km2. In the case P is to PB is M1 is to M2. Then we can write a segment formula. Segment formula. P is a point which dividing the line segment AB in the ratio M1 is to M2. Then we can find the coordinates of P using the formula. P is equal to M1 x2 plus M1 x2 plus M2 x1. M1 x2 plus M2 x1 by M1 plus M2. It is the first coordinate. Second coordinate is M1 y2 plus M2 y1 by M1 plus M2. We call this as section formula. The point which divides the line segment joining AB, the point which divides the line segment joining x1 y1 b x2 y2 in the ratio m1 is to n. M1 is to M2. The point which divides the line segment joining A x1 y1 b x2 y2 in the ratio m1 is to m2 is ordered by m1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by M1 plus M1 x2 plus M2 x1 by M1 plus M2 with x2 x1 and M1 M2 we can get x coordinate by using y1 y2 and M1 M2 we can write second coordinate M1 y2 plus M2 y1 by M1 plus M2. And one more. Here, on the other hand, we can write that there is a line segment joining AB. AB is a line segment. P is a point on AB. If A is described with the order pair x1 y1, b is x2 y2, and ratio m1 is to m2 is taken as 3:1. Then we can write internally dividing point P. Then P is equal to internally dividing point P is equal to kx2 order pair kx2 plus x1 by k plus 1. If m1 is to m2 is equal to 3:1, then we can write y coordinate as ky2 plus y1 by k plus 1. So segment formula in case of the ratio m1 is to m2 and endpoints of the line segment x1 y1 bx2 y2, there is m1 order pair m1 x2 plus m2 x1 by m1 plus m2 comma m1 y2 plus m2 y1 by m1 plus m2. In case of ratio is to 1, we can write this segment formula as order pair kx2 plus x1 by k plus 1, ky2 plus y1 by k plus 1. It is using this formula we can find internally dividing point. There is a line segment AB and P lies on the line segment AB. Then we say P divides AB internally. Here P divides AB internally. And there is a line segment AB, and if P divides on AB produced, if P lies on AB produced, then we say P divides AB externally. If P lies on AB, then we say P divides AB internally. If P lies on AB produced, then we say P divides AB externally. Let us write these points. If the point P lies on the line segment AB, if the point P lies on the line segment AB, then we say P divides AB internally. P divides AB internally. If suppose P is dividing AB internally in the ratio m1 is to m2, that means P is to PB is m1 is to m2 and A is x1 y1 and B is x2 y2, then we can find internally dividing point P. This is like A x1 y1, B is x2 y2, and the ratio P is to PB is m1 is to m2. The ratio is m1 is to m2. Then we can find internally dividing point P. Then internally dividing point internal dividing point P is equal to order by m1 x2 plus m2 x1 by m1 plus m2. m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. m1 y2 plus m2 y1 by m1 plus m2. On the other hand, if P lies on AB produced, then we say P divides AB externally. If P lies on AB produced, if the point P lies on the line segment AB produced, then we say P divides AB externally. P divides AB externally. If A is described with the vector x1 y1 and if B is x2 y2, then we can find P. Externally dividing point P we can find. If we know the ratio PA is to PB, PA is some M1 K M1 and PB is K M2 for some constant K. That means PA is to PB is KM1 is to KM2. That means M1 is to M2. Then we can find external dividing point P. If A x1 y1, B x2 y2, and ratio M1 is to M2, then we can write externally dividing point P formula. Externally dividing point P is equal to M1 x2 minus M2 x1 by M1 minus M2. M1 x2 minus M2 x1 by M1 minus M2. Order pair M1 x2 minus M2 x1 by M1 minus M2, comma M1 y2 minus M2 y1 by M1 minus M2. M1 y2 minus M2 y1 by M1 minus M2. So we have internally dividing point formula under pair M1 x2 plus M2 x1 by M1 plus M2, comma M1 y2 plus M2 y1 by M1 plus M2. In case of externally dividing, here plus minus, here plus minus, here plus replaced minus, here plus replaced minus. That means M1 x2 minus M2 x1 by M1 minus M2, M1 y2 minus M2 y1 by M1 minus M2. These coordinates are for externally dividing point. There is a line segment AB. And there is a point P on AB, so that P is equal to PB. If P is equal to PB, then P divides this line segment into two congruent parts, so that P is called bisecting point of AB. Then P is called as bisecting point. of AB, of the line segment A. As P divides this line segment into two congruent parts, two equal parts. I took the line segment AB, and there are 2 points on AB. There are 2 points PQ on AB, so that PA is equal to PQ is equal to Q. Line segment PA is equal to line segment PQ is equal to line segment QB. That means PQ divides this line segment AB into 3 equal parts. Then we call these points PQ as a trisectional points. If P is equal to PQ is equal to BQ, then P comma Q are called as trisectional points. Trisectional points. What are the trisectional points? The points which divides the given line segment into 3 congruent parts, 3 equal parts, is called trisectional points. Trisectional points. Let us write trisectional points. Definition. The points which divides the given line segment into 3 equal parts. PA is equal to PQ is equal to BQ. Then PQ are called as trisectional points. The points which divides the given line segment into 3 equal parts. Are called trisectional points. What is the trisectional ratio? For example, I am taking a bar chocolate. There is a bar chocolate. In which there are 3 congruent parts. There are 3 congruent pieces in that. We can distribute these pieces among 2 children in this way. To the first person 1 piece, and to the second one 2. That means distributing 1:2 ratio. Otherwise, to the first person 1 and to the second person 2. That is one way. On the other hand, to the first person 2 and to the second person 1. You can distribute in that manner also. That is first person 2, second person 1. That means 2:1 ratio. When we are dividing into 3 parts, we can distribute in 2 ways, 1:2 or 2:1. Like a way, there is a line segment AB. And there are 2 points PQ on AB, as PQ are the trisectional points. PQ divides this line segment into 3 congruent parts. Then PQ are called trisectional points. This trisection ratio is here P is to PB. If we take P is to PB, that is it is one part and it is PB is two parts. It is 1 is to 2. So trisection ratio is 1 is to 2. Or here QA is to QB. QA is to QB is 2 is to 1. So trisection ratio is 1 is to 2 or 2 is to 1. If to find the trisectional points, we need to proceed with the ratio 1 is to 2 so that we get the first trisectional point. Then if we proceed with the ratio 2 is to 1, then we get second trisectional point. So trisectional ratio is 1 is to 2 or 2 is to 1. So bisection ratio is 1 is to 1. Trisection ratio is 1 is to 2 or 2 is to 1. Now let us divide a line segment into 4 equal parts. If there is a line segment AB, and there are 3 points on AB. There are 3 points P, Q, R are on AB. So that P is equal to PQ, P is equal to PQ, and PQ is equal to RQ, and RQ is equal to RB. Then because if PQ are dividing line segment AB into 4 congruent parts, 1, 2, 3, 4. PA is equal to PQ is equal to RQ is equal to RB. The points PQ are dividing line segment AB into 4 equal parts. If AB is a line segment and P, Q, R are 3 points on the line segment, lie on the line segment, so that P is equal to PQ is equal to RQ is equal to RB. Then we say PQ are dividing AB into 4 equal parts. PQ are dividing AB into 4 equal parts. Are four congruent parts. Then when the points are dividing the given line segment into 4 equal parts, let us write the ratio. See, I am taking a bar chocolate which is made into 4 congruent parts. A bar chocolate is made into 4 congruent parts. 1, 2, 3, 4. We can divide these 4 pieces among 2 children in this manner. First part is to the first person and remaining 3 to the second person. That means the ratio is 1:3. And first 2 parts to the first person and the remaining 2 parts to the second person. Then the ratio is 2:2. That is nothing but 1:1. 2:2 is nothing but 1:1. Next, first 3 parts to the first person, remaining 1 part to the second person. Then the ratio is 3:1. When we are dividing this bar chocolate into 4 congruent parts, 4 equal parts, then we got the ratio 1:3 or 1:1 or 3:1. In the same manner, when we are dividing a line segment into 4 equal parts, we will have the ratio 1:3 or 1:1 or 3:1. Here, when a line segment is divided into 4 equal parts, then the ratio is here. This is a line segment AB. P may divides AB into 1:3 ratio. 1:3. That is ratio is 1:3. Or here P is 1 part, PB is 3 parts. Otherwise, there is a point Q. Q divides AB. Q divides AB in the ratio 2:2. That means 2:2. Here P is to P. Here P is to PB. Here P is to PB is 1:3. Here AB and Q is in the middle, and it is QA is to QB. Here 2 parts and here 2 parts. So QA is to QB is 2:2. That is nothing but 1:1. So ratio is 1:3 or 1:1. Or if we take R on AB, if we take R on AB, then the ratio RA is to RB. RA is 1, 2, 3, 3 parts is to RB is 1 part, 3:1. There is 3:1. When a line segment is divided into 4 equal parts, then the ratio is 1:3 or 1:1 or 3:1. Now let us know finding fourth vertex of a parallelogram. There is a parallelogram ABCD. And 3 vertices are given: A x1 y1, B x2 y2, C x3 y3, and we need to find a fourth vertex B. We have a formula: if A x1 y1, B x2 y2, and C x3 y3 are the three vertices of a parallelogram. Taken in order, taken in order. Then the fourth vertex D. Then the fourth vertex D is equal to, add the cross ones and then subtract x1 plus x3 minus x2. x1 plus x3 minus x2 gives the x coordinate of the fourth vertex, and y1 plus y3 minus y2. y1 plus y3 minus y2. Using this formula, we can find fourth vertex directly. Let us prove it. We know in a parallelogram, diagonals bisect each other. That means midpoint of AC is equal to midpoint of BD. In parallelogram, midpoint of AC is equal to midpoint of BD. That means diagonals bisect each other. Here D we don't know. Let us take the coordinates of D as A comma B. Now we need to find first coordinate A and second coordinate B. Midpoint of EC, midpoint of x1 y1 and x3 y3. We have formula x1 plus x3 by 2 and y1 plus y3 by 2. Midpoint of BD, we have the formula x2 plus a by 2, x2 plus a by 2 and y2 plus b by 2. Let us equate these two order planes. Equate the first coordinate and first coordinate, second coordinate and second coordinate. So x1 plus x3 by 2, x1 plus x3 by 2 is equal to x2 plus a by 2. On the other hand, y1 plus y3 by 2 is equal to y2 plus b by 2. Here by 2 and by 2 can get cancelled. x1 plus x3 by x1 plus x3 is equal to x2 plus a transpose plus x2 to the left. So x1 plus x3 minus x2 is a. x1 plus x3 minus x2 is a. Here by 2 get cancelled. y1 plus y3 is equal to y2 plus b plus y2 transpose to the left, so that become minus y2. y1 plus y3 minus y2 is equal to b. We have a is equal to x1 plus x3 minus y2. A is equal to x1 plus x3 minus x2. b is equal to y1 plus y3 minus y2. In fact, fourth vertex D is equal to arbitrary AB. Now we have A is x1 plus x3 minus x2. x1 plus x3 minus x2, and B is y1 plus y3 minus y2. y1 plus y3 minus y2. So we got fourth vertex. Fourth vertex, the formula x1 plus x3 minus x2 and y1 plus y3 minus y2. Using x coordinates of these three vertices, we can find x coordinate of B using by add cross x1 plus x3 and subtract the remaining one minus x2, x1 plus x3 minus x2, that is x1 plus x3 minus y. Using y coordinates of these three vertices, we can write the y coordinate of the fourth vertex. Y add the cross ones, y1 plus y3 minus y2, that gives second coordinate of fourth vertex. So if we know three vertices of a parallelogram, we can find fourth vertex using the formula D is equal to order by x1 plus x3 minus x2, comma y1 plus y3 minus y2. Same formula can be used for finding fourth vertex of a rectangle or a rhombus or square. We know that in a triangle, median's intersecting point is called centroid. There is a triangle ABC. Triangle ABC. AD is a median. B is a median. CF is a median. Concurrence of medians in a triangle. Median's intersecting point is called centroid Z. If we know the vertices x1 y3, x1 y1, bx2 y2, and cx3 y3. If we know the vertices of a triangle, we can find centroid Z using the formula x1 plus x2 plus x3 by 3, x1 plus x2 plus x3 by 3. Average of the x coordinates, we get the x coordinate of the centroid. By taking the average of y coordinates of these three vertices, we get the y coordinate of centroid. y1 plus y2 plus y3 by 3. So, median's intersecting point, if A x1 y1, B x2 y2, C x3 y3 are the vertices of triangle ABC. Triangle ABC, then median's intersecting point formula median's intersecting point generally we denote with Z, that is order 5 x1 plus x2 plus x3 by 3 y1 plus y2 plus y3 by 3. And one more, centroid median's intersecting point is called as centroid G. Median's intersecting point means centroid G formula under by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Centroid is also called as the center of gravity. center of gravity Z formula order pair x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3 with the formula to find centroid of a given triangle. And one more, centroid divides the median in the ratio 2:1, 2x, 1x. It is 2 into some constant, 1 into that constant, 1x. So AZ is to ZD is 2:1. Centroid divides median in the ratio 2:1. Centroid divides the median in the ratio 2:1. That means here we have AZ is to GD. AZ is to ZD is 2:1. On the other hand, BZ is to ZE. It is also 2:1. BZ is to GE is 2:1. CZ is to ZF is 2:1. AZ is to ZD is 2:1. BZ is to GE is 2:1. CZ is to GF is 2:1.